Here we have a TRP operon, which is a repressible operon. So first we're going to exemplify what happens when the operon is turned on. So here we have the regulatory gene, which contains the directions for the repressor protein. So it creates mRNA through transcription, which is then translated through the ribosome, and thus the repressor protein is created. But right now it's inactive because there's no co-repressor to bind it. So the RNA polymerase is free to bind to the promoter, which we see up here, and able to transcribe down the structural genes and create mRNA, which has the directions for TRP. So the mRNA is then translated with the ribosomes, and the proteins needed to make TRP are made, which we can see here exemplified by these little pink pieces. Those are the proteins to make TRP. And thus that's what happens when the operon is active. So once these TRP are already present, the operon will be turned off. So here we'll see what happens when the operon is turned off. This repressor protein will become active by the co-repressor binding to it, and then it will change shape. So once it changes shape, it'll be shape specific to fit into the operator. We can see happening here, changing shape, and binds to the operator. Then the RNA polymerase binding to the promoter won't be able to move past the operator to read the structural genes and won't be able to make any mRNA, and thus there will be no protein created when this operon is off.